Welcome to Penrose Learning, where we make understanding easy.
You start by preparing the environment and data. Create a Python 3, 8 plus virtualenv, install Tensorflow and core libs, then load your CSV or TF record. Once done, split your data 80/20 for training and validation. Normalize numeric features to the 0-1 range so gradients behave. Next, define input pipelines with TF. Data for batching and shuffling. Make sure to inspect shapes and d-types. Mismatched tensors cause subtle bugs, so log a few batches before moving on. You now design and compile the network. Choose sequential for simple stacks or functional when you need multiple inputs or skip connections. Pick ReLU, Sigmoid, or Softmax based on output. Compile with Atom or SGD, set an explicit learning rate and appropriate loss, categorical cross-entropy for multi-class, MSE for regression. Once compiled, train with model. Fit using TF, data batches, and add callbacks like early stopping and model checkpoint. During training, monitor loss and metrics in TensorBoard so you can adjust hyperparameters quickly. You finish by evaluating and exporting the trained model. Run model. Evaluate on a held-out test set, then inspect confusion matrices or regression residuals to validate behavior. Once satisfied, save as saved model or HDF5 and bundle preprocessing steps so deployment replicates training inputs. If performance falters, try a targeted troubleshooting step. Check for data leakage, lower the learning rate, add gradient clipping, or simplify the model. If training diverges, rewind to diagnostics, inspect inputs, layer outputs, and weight histograms to find the cause.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.